pick up where we left off here. And we're going to be on number 10. And this denominator factors. This is k minus 6 and k minus 2. That adds up to 8 and still gives us 12, which is what these factors are, so nice and easy. So we're going to multiply everything by both k minus 2 and k minus 6. So do this one by k minus 6 and k minus 2, and the last one by k minus 2 and k minus 6. So all three get multiplied by the same thing. Here, both cancel. The only thing left there is 4. Here, k minus 2 cancels, leaving me with k times k minus 6 plus k minus 6 cancels, leaving me with 1 times k minus 2. So we just have some multiplying to do. So I'm going to have 4 equals k squared minus 6k plus k minus 2. I can set that equals 0. I have k squared. Combine these like terms together is minus 5k. And then when I subtract 4 over, gives me minus 6. So factors of 6 would give me negative 5. So that's going to be k minus 6 and k plus 1. So I get 6, k equals 6 and negative 1. But 6 is one of my restrictions. So that is extraneous, and the answer is just negative 1. Alright, let's go to the work time. Okay, so number 11 here, we are not doing this one. We're not intending for this one to be on there. So that is not one that you have to do. So we're going to go to graphing now. We just came through this. So I'm going to start with number 9. I'm going to factor cancel this by taking a 3x out, and we with x minus 4, and factoring this into x minus 3 and x plus 1. So what I have then are a horizontal, I'll do it over here to the left, horizontal asymptote, y equals equal degrees, so I use the leading coefficient, which is 3 over 1, or 3. The y-intercept comes from the constants, which there's an unseen 0. 0 divided by 3 is 0. The vertical asymptote, nothing is being shared, so both positive 3 and negative 1 are vertical asymptotes. X equals negative 1 and x equals positive 3. So there's no hole, there's nothing to share. There are two x-intercepts. Zeros in the numerator are 0 and 4. So 0, comma 0, which we already had, and 4, comma 0. So I'm going to plot at 4 at 0, comma 0. I'm going to draw an asymptote at negative 1. I'm going to draw an asymptote at 3. And a horizontal asymptote at y equals 3. And I have all my sections. And we just need some additional points for these sections. Now this one's going to go like this when you plug in some points. This one is going to come through like this, hit that, and fall down. And then this one's going to be up here in this section. And you just need to get those additional points. All right, let's go to 10. Let's do a little factoring. Take out an x, and I'm left with x squared minus 16, which factors conjugate x plus 4, x minus 4. Over, take out a negative 4. When you take negative 4 out, you would get x squared minus 1, x minus 6. So that's x minus 3 and x plus 2. So again, nothing being shared here, so there's no hole. There's a horizontal asymptote of none, because the numerator is bigger. We'll find the oblique in a moment. There's a y-intercept, that's 0, comma 0. Again, that's 0 over 24. There's space here. Now the zeros. The numerator zeros are 0, negative 4, and positive 4. And the denominator is 3 and negative 2. And the vertical asymptotes are x equals 3 and x equals negative 2. The x-intercepts already have 0, 0, with negative 4, comma 0 and positive 4, comma 0. I do need the oblique here. So I'm going to take x to the third plus 0x squared minus 16x divided by negative 4x squared plus 4x plus 24. So 1 divided by negative 4 is negative 1/4 for the slope. When I multiply back through, I get 1x to the third minus 1x squared. And when I subtract a negative 1, it becomes positive 1. So again, I have 1 divided by negative 4, or negative 1/4. So I'm going to plot from negative 1/4, my y-intercept. I'm going to go down 1 over 4. And there's my oblique. I can go up 1 over 4. And there's my oblique in this direction. I have points at negative 4 and positive 4 on the x-axis. Vertical asymptote at 3 and at negative 2. I have a point at 0, 0, which is just above that oblique asymptote. And so what I would see is something like this, or it comes down like this, comes down like this, which means it's coming down, passing through and going down this way when you get the additional points. Alright, let's go to 8. Now I have 4 of these. You don't have to do all 4 of these, but if you need the extra practice, I gave you plenty of them. In fact, this one is very similar to the last one, so you wouldn't have to necessarily do both. And that's fine if you do not. Plus 1. So here's my factors. And so x minus 3 is being shared, so there will be a hole on this one. I'm just going to list all the zeros. 0. But let's go through. Horizontal asymptote. The numerator's bigger, so there is none again. We'll find an oblique in a moment. The y-intercept is 0, 0 once again. Vertical asymptote. 3 is being shared, so the negative 1 is the only vertical asymptote. The hole is at 3. 3 comma what? Well, the reduced form of this would have an x plus 3, the x minus 3 is cancelled, over 3 and x plus 1. So when I plug 3 into this, that would give me 18 over 12 over 3 halves, 1.5. There's my hole. And then the x-intercepts are at 0, 0, already have that, and negative 3, the other 0 in the numerator. Now we need our oblique. So I'm going to divide x to the third plus 0x squared minus 9x divided by 3x squared minus 6x minus 9. So when I do 1 divided by 3, that's 1/3 x. Multiply that through gives me 1. 1/3 times negative 6 is negative 2. And then when I subtract, negative 2 turns into positive 2. So 2 divided by 3 means the y-intercept is 2/3. So from the y-intercept to 2/3, I go up 1 over 3. Here's my oblique this way, down 1, back 3. Here's my oblique this way. 0, 0 is an intercept. Negative 1 is an x. Is a vertical asymptote. There is a hole at 3, 1.5, which is right here. And at negative 3, there's an x-intercept. So when you get the additional points, although on the final, you're probably just going to be asked to sketch, not do too much with additional points. Use those to make a nice, neat sketch. Alright, let's do the last one here. This one has a horizontal asymptote, y equals 2. The degrees are equal. I have a y-intercept of constants, 12 over 2. So that would be 0, 6. 12 divided by 2. Vertical asymptotes, we need the factor. This would be a 2. When I take 2 out, I get x squared plus 5x plus 6, which factors into x plus 3 and x plus 2. In the denominator, I have x plus 2 and x plus 1. And so my zeros are negative 3, negative 2, negative 2, negative 1. The negative 2 is shared, so that's the hole. Negative 1 is the one that's not shared in the denominator. So that's the vertical asymptote. The hole is at negative 2 comma something, and the x-intercept is the remaining numerator 0 of negative 3 comma 0. Now the reduced form of this would be 2 times x plus 3. The x plus 2 is canceled, and x plus 1. When I plug negative 2 into that reduced form, I would get 2 over negative 1 or negative 2. So negative 2 is a whole. X equals negative 1 is a vertical asymptote. Y-intercept is 6. Horizontal asymptote at 2. X-intercept is negative 3. follow the asymptote, get the hole, jump over the hole, follow the asymptote, get your point, follow the asymptote, done. Alright, let's jump down to these 37. So we're going to add these. To add these, I need common denominators. So I have x plus 5 over, factor it, x plus 4 and x minus 1, plus x plus 2 over, factor it, x plus 1 and x minus 1, conjugate rule. So this side needs an additional x plus 1 to give it a common denominator. This side needs an additional x plus 4 to give it the full common denominator. So what I have then is x plus 1 times x plus 5. We'll distribute that out. X squared plus 6x plus 5 plus, distribute this out, gives me x squared plus 6x plus 8. And that's all over top of the common denominator, which is the 3 parentheses. So when I combine my terms, I get 2x squared plus 12x's plus 13 over x plus 1, x minus 1, and x plus 4, final answer. Again, we're adding and subtracting here. Now notice this one's backwards, so I'm going to rewrite that. So I'm going to write it as 4x over, now this denominator factors into x plus 1, x minus 1, plus negative 3x. By taking the negative out, I can turn that around and make it x minus 1. And x minus 1. So x minus 1 is in common with all of them. What we need then are some x plus 1. So this needs an x plus 1, and this needs an x plus 1 on top and on bottom. So what I have then when I simplify the 4x from the first denominator, and then negative 3x times x is negative 3x squared, negative 3x times 1 is negative 3x. When I distribute the negative 4, I get negative 4x minus 4, so I distribute the negative with it. Let's combine my terms. I have negative 3x squared. I have 1x. Excuse the jump. Right, let me go back to this point right here. So when I combine these like terms together, I have negative 3x squared. When I put all three of these x's together, I end up with minus 3x and then the minus 4th, and all over that common denominator of x plus 1, x minus 1. Okay, you do not have to do the next 149. I realize how difficult it is. It won't be one that hard on the test. So I'm going to jump to 50. This one has denominators 1, x minus 3x plus 3, and x minus 3. So I'm going to use the strategy of clearing fractions. So I'm going to multiply everything by x minus 3 and x plus 3. Actually, you know what? When I look at it, that's going to create a big mess there. So I'm going to take that back. So let's not do that. Let's just make common denominators up top here. So I'm going to multiply top and bottom by x minus 3. Now the numerator has common denominators. So when I distribute this, I get x squared minus 6x plus 9 minus x minus 5 when I distribute this negative over the common denominator of x minus 3. I'll clean that up in a minute. Down here, this side needs x minus 3. This side needs x plus 3. So then that becomes, distribute the 2, 2x minus 6, plus distribute the x here, x squared plus 3x, all over top of the common denominator of x plus 3, x minus 3. So let's clean this up now. So what I have is x squared minus 7x plus 4 in the numerator over x minus 3 over x squared plus 5x minus 6 over x plus 3 and x minus 3. So when I flip this, we multiply by the reciprocal, x plus 3 and x minus 3 end up on top. And this gets flipped up. X squared plus 5x minus 6 is on the bottom. X minus 3's cancel.